Okay, so we will try to solve contest problems. So the contest is now going. So first we should register for the contest. Okay, let me grab a copy and pen. So we have registered for the contest, and now we will open this question in separate tab. Okay, we have opened the question. So we will start with this medium problem. First medium problem, which is you are given a string word and an integer num friends. Alice is organizing a game for her num friends. There are multiple rounds in the game, wherein each round word is split into num friend non-empty string such that no previous round has had the exact same split. Okay, all the split words are put in a box. Find the lexicographically largest string from the box after all the rounds are finished. Okay, a string A is a lexicographically smaller than B if in the first position where A and B differ, string A has a letter that appears earlier in alphabet than corresponding letter B. In the first minimum length characters do not differ, then the shorter string is the lexicographically smaller one. Okay. So for example, DBCA is a word and this variable is 2. So all possible splits are this and this, this and this and this. Okay, so all possible splits are this and this. Okay, the word length is 5 into 10 to the power 3. So basically we are given a word and we need to divide it into these much parts, means these much parts. So here we are dividing this string into two parts, this part, this part, this part, means all the possible permutations, and we need to return the lexicographically smaller string. Okay, lexicographically smaller string. Okay, we need to return lexicographically largest string. We know that if two strings which whose characters don't differ, then the minimum length string with the minimum length is considered as the lexicographically smaller. Okay, the shorter string will be lexicographically smaller. Okay, suppose we divide all these strings into these. Let's say this is n variable, so n minus 1 splits. Means in n minus 1 splits we can split string with a single character, and then we have a remaining character whose length will be greater or than equal to 1, and we can check which is greater. I think this can work. This is smaller than equal to word dot length. So let's say, so length of our string will be word dot length, and let's say this as the n. So what we can do is I think we can have n minus 1 strings with length 1, and we can look up for max lexicography larger string whose length will be with length will be this length minus n minus 1. For example, here our length of the string is 4, so here length is 4, so 4 minus here our num friends is 2, minus 2, and this will add up, this one will get add up, so plus 1, so this gives us 3. Means our answer can be of length 3, which is here is 3. And similarly for this case, n minus 1 is 3, so 4 minus 3 is 1, so our answer is of 1 length. So I think we need to find a string. So our window size will be, let's say our window size is length minus n minus 1, and let's say our answer string is initially empty, and at the end we will return our answer string. Okay, we can define our size here itself. Okay, so we will now find string of every window, every size of this window. So for int I equals to 0, I less than equals to length minus size I plus plus. So we will, our current substring is string substring will be word dot substring I plus size, and we can compare if greater, means if it's greater lexicographically, means if our substring is greater than our answer lexicographically, in that case we can replace our answer with that substring. Then now we need to implement the function private boolean greater, which will take two strings, string A and string B. So So we need to check if a is greater than b. If a is greater than b, so we will initialize two pointers I and j from 0 while our I is smaller than a dot length and our j is smaller than b dot length. What we can do, we can compare characters. So if we need to this compare this. Okay, if a dot char at I is smaller than b dot char at j, then in that case we return false, and we will increment I as well as j, and at the end we compare. If our I becomes 0, sorry, I becomes a dot length, in that case we have reached the end of a string, means a string is shorter than b. Okay, we can also okay, then in that case we can return false, otherwise at last we will return true. Let's run the code. Okay, we have got some compilation error. Cannot find symbol answer. Okay, why cannot find symbol answer? Okay, we will return true, not answer here. Okay, this is our answer for first string. Let's use remaining test cases. Okay, our answer is G here. I think this should work. Let's try to submit this. Okay, we have got a wrong answer for this string BIF, where this is 2. Okay, so we have a input for which we have gotten a wrong answer, so let's figure it out. So we have BIF, so our length is 3, meaning our length is 3 and our n is 2. Okay, so this is string, our length is 3 and this is 2, so our size will be length minus 1, so length minus 1 is 2, so our answer will be substring of length 2. Okay, our answer will be substring of length 2. We are returning BI and expected answer is IF. Okay, 3 minus 2. Okay, 3 minus 1. Yes, so our size will be 2. Why 2? Because it's 3 minus n minus 1, which is equals to 2. So till which position our this will go? This will go till length is 3. 3 minus 2 is 1. 3 minus 2 is 1, so 0 and 1 is, it will run for 0 and 1. So initial string will be 0 0 to 2, then it will be 1 to 3. Okay, so we will check if our substring, initial substring will be BI. We will check if BI is greater than empty string. So what we are checking, BI as A and empty string as B. So this condition will fail because our B is empty, and we will check if our I is equals to A dot length. No, I is not equals to A dot length, so we will return true and our answer will store BI. Then we go on next iteration. Now we will our I is 1 and our I plus size is 3, so 1 2 3 0 1 2. So now our substring will be if, and we will check if if is greater than bi. So let's figure out. So our we have initialized our I variable as 0 and j variable as 0, so both are smaller than the length. Now we compare a dot I, which is this, and then this. If a dot I is smaller than b dot character at j, no, it's not smaller. If it's smaller, then we will return false, and if it's greater, then b dot char at j, then in that case we will return true. I think this should work now. We can use this example test case to check. Okay, so if is now our answer, so let's submit this. Okay, we still got a wrong submission. Okay, so in this case we are giving a substring of length 3, but answer can also be substring of length 2. Okay, from the end also we need to check. Means from we have checked this string, now we need to check our rest of the string. Okay, for int I equals to length minus size plus 1 to I smaller than n smaller than length I plus plus cd command p let's see, let's paste this here, see if this is working. Okay, code is working, giving n. Let's submit this. We are still getting wrong answer. Okay, we need to divide it into one part only, and we are dividing it here into multiple parts. Are we making any other mistake? Let me think. We have covered all these strings and Okay. Okay, running for this test case. Let's see if it's okay. Let's submit our approach. Okay, we have our solution is accepted. So let's move to the next question. So you are given a m into n matrix grid consisting of non-negative integers. Okay, in one operation you can increment the value of any grid I and j by value 1. Okay, return the minimum number of operations needed to make all columns grid strictly increasing. Here 15 operations are needed. You are given a matrix consisting of non-negative integers. In one operation you can increment value of any cell by 1. Return minimum number of operations to make all columns of the grid strictly increasing. Okay, we need to make a strictly increasing all grids of all column values. So we will iterate all column values. Let's say in order to iterate columns, first we will what we will do, our int n is equals to grid dot length and our n is equals to grid 0 dot length, and let's also initialize our answer variable. Here answer equals to 0. At the end we will return our answer. Now we need to iterate our columns. So in order to iterate the columns, what we can do is so this is our column, so we can iterate all our columns for int j equals to 0 and j smaller than n, j plus plus. Okay, so we will start from next row, and we will consider the previous value. So our previous value here will be value grid from row 0 and column I. Okay, from 0th column. So basically this is column. So we will check if our value, basically we will compare this value. So this is our previous value 3 and we will compare 2 with this 3. So we will compare 2 with this 3. If our grid if our value in this column is smaller than, if it's smaller than its previous value, then in that case we will increment our answer as means previous value is greater. So what we will do, we will subtract our current value from our previous value and add 1 to it. So this is the minimum we can do. We can increment 1. For example, first we will make this 2 equals to 3. That will take 3 minus 2, one value to make it equal, and one another value to make it greater. So that's why we are only incrementing 1. Okay, so we have added it to our answer. Now we need to update our previous value also. So let's say int difference is this, and we will means this much value we need to add to make our value this, and our let's make difference 0 initially, and this will put some value in our difference. Okay, so this much difference, this much value we need to add. We will add that difference to our answer variable, and we will make our previous value is grid j I plus difference is will be our previous value here. So I think this should work. Let's run this. Okay, so we are getting 15. Let's see another example. So for first we are getting 15, and for second we are getting 12. Second we are getting 12. Let's submit this. Okay, we got a wrong answer. Okay, so I think equal values are also accepted. No. Return the minimum operations to make all columns of the grid strictly increasing. Our function returning 0 for this, but it should return 2. So let's figure out why it's returning. So for first column our previous value will be this 0. Then we start from this row and difference is 0. We compare if it's we need to add equal sign also, so that was mistake we were doing. We can check, cross check our answer by running this test case. Okay, so we are getting 2 now, so we can submit it now. Okay, we have got a submission. So we have submitted 2 questions. Let's move to the third medium problem. So the problem says count special subsequences. You are given an array nums consisting of positive integers. Okay, we have an array of positive integers. A special subsequence is defined as the subsequence of length 4. Okay, subsequence of length 4 represented by indices p, q, r, s, where okay, p is greater than q, r is greater than s. This subsequence must satisfy the following condition. Okay, the multiplication of p and r, p and this r should be equal to q and s. Okay, okay, there must be at least one element between each pair of indices. In other words, there must be at least one element between each pair of indices. In other word, q minus p should be greater than 1. Okay, a subsequence is a sequence derived from array deleting 0 or more without changing the order of remaining elements. Return the number of different special subsequences in nums. Okay, so these two conditions we need to, these three conditions we need to maintain. We need to pick 4 elements from this array in increasing order, and then this condition also should satisfy, and then also they must be separated by at least one index. Okay, so can we use dynamic programming here? We need to pick 4 elements and their indices also. Okay, nums of p by, okay, we can rewrite this condition as suppose we have this condition. I think we can rewrite this condition as nums p. We can remove this from here and move here. We can remove this from here, this from here, move here. So p, q, s, r, p, q, then s, r. Okay, I think we should use dynamic programming here. Using dynamic programming we can skip one character also, means one index also, and we can check if our previous chosen character was smaller than the current element. So I think we can use dynamic programming. So let's say we call a function find, and this is our array. Initially we are at 0th index, and number of variables we have chosen means we need to choose 4 variables. So suppose initially we have chosen 0 variables. So public, let's say long find in nums, this is our index, this is our count we have chosen. So if our count reaches 4, then this means we have chosen all the 4 values. For now we are returning 0. Okay, so what we can do in dynamic programming is we can skip the current value, that we are not interested in choosing a particular value from our array. Means initially we are at 1 and we don't want to choose the 1, so we can skip 1. So we can call nums and we can increment our index, and our count will remain same as we haven't chosen any value. And other thing we can do is also I think we need previous value. Let's say our previous value is -1. So if we can choose a element if our previous value is -1, or our if previous value is not -1, instead of value let consider this as previous index, and our current number is greater than our previous number, then in that case we can choose the current number. So these two situations we can choose a current number. So let's say skip is equals to what we need to return. We need to return total number of special subsequences. Okay, let's say we return 1, means we have found a special subsequence. Okay, what we will do here is we will do a math dot skip, and we choose current. If we choose a current number, so our count will increase, and our previous value will be now this current index. But we need to do index plus 2, because we need to put a gap here, which is 1 gap. So our this condition is satisfied and this condition is satisfied. Now our this condition is not satisfying. We need to see that how we can implement this condition also. Means what does this condition means? Nums of p into r should be equal to q into s, means 0 to 4 6 1 3 5 7, means 3 into 7. Wait a second. P into r means 1 into 5. Okay, is 16. Okay, our indices need to be greater, not our values. Okay, we can skip this part. Okay, as we are moving forward, then our indices will automatically be greater, and to maintain a gap in the take condition we can do this. So let's call this intake. Okay, we need to maintain this condition, so we are getting stuck in this condition, that how we can maintain this condition. P by P into R must be equal to Q into S. A spatial subsequence defined length 4 represented by indices PQRS, while P subsequent must satisfy the following conditions: P into R Q into S. PQRS. PQRS. And this value should be greater than this value. Okay. P here, Q here. So P by Q should be equal to S by R. Or P by S. P by S should be equal to Q by R. Means P by S. Okay. P by P into R means we can make conditions like P by S should be equal to this value. Will it make any sense? Means the end two values should be equals. The fact is we only need to pick four values. We only need to pick four values. Suppose initially we can take two values. We can choose two values and call our next function to choose another two values. But which two values we can choose first? P and Q means initially we choose P and Q and their division must be equal to S by R in the next values. Okay. P by Q, or we can rewrite this condition as okay. Suppose we look for two values. First let's define n. So nums dot length for int I equals to 0, I less than I plus plus, and for int j is equals to I plus 2. We need to skip one element in between, so j is smaller than n and j plus plus. So our p value will be nums of I, and our this q value will be nums of j. And now suppose we need to find, we call our find function that in rest of the array find the two elements R and S. So P by Q, Q by P means whose division means find two elements whose division is equal to this nums of Q by nums of P, starting from index j plus 2. Why j plus 2? We are skipping an element in between. So how many pairs you can find? So if I define a variable int answer here, which is a long answer here, which is 0 initially, and I can add this find variable to my answer. At the end I can return my answer. How I can find my answer? I need to find only two values. Dividing them will give me q by p. Means I need a approach which can work in time complexity somewhere like n square and log n. N square log n will work. So this will not work in log n. J plus 2. Okay. Okay, we need to solve this problem. So the problem says we need to figure out this variable. Okay. Nums of p by s should be equal to q by r. Array is not sorted. Hmm. Only 182 users have submitted the accepted solution. Let's look at the last question. You are given three integers n, m, k, a good array of size n defined as follows. Each element in array is inclusive, range 1 to m. Exactly k indices I satisfy the condition. Okay. Written the good arrays that can be formed. Number of good arrays. What are good arrays? A good array is defined as follows. Each element in an array is inclusive of the range 1 and m. Okay, 1 to 2. Exactly k indices satisfies the condition. Okay.